Good afternoon, everyone, and thank you for joining in on our webinar this afternoon on unpacking the new VCE Foundation Maths Study Designs with Cambridge Senior Mathematics. My name is Kim Keane and I'm the National Webinar Presenter for Cambridge University Press and Assessment. Before I make a start, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Please know this webinar is being recorded. You'll receive a link in this recording along with the opportunity to give feedback on your experience this evening. You can expect to see this email arrive in your inbox within a week. You can ask questions throughout the webinar in a chat box. We'll be constantly monitoring this throughout the webinar. So if you're not able to get all questions, or if we're not able to get all the questions responded to, please know that you can add them into the chat box at any point in time throughout the webinar. If you'd prefer to wait until the end, you can ask any questions during the live Q&A session with all the authors and Cambridge team members all present there. It's important to note, though, that this evening's webinar has a large number of attendees and there will be limited time for our Q&A, so please feel comfortable to add your questions into the chat box. I'll be detailing publication, page proof dates and product pricing at the end of the webinar, so please stay tuned for that. Before we begin, I'd like to introduce you to our esteemed authors who'll be speaking this evening. Dave Tout, he's an experienced numeracy and maths educator who's particularly interested in making maths relevant, interesting and fun for all students, especially those students who are disengaged from mathematics. He has 50 years educational experience, mainly in the vet sector, working in schools, TAFEs, community providers, universities and workplaces. Dave has written numerous teaching resources and has been involved in various curriculum developments. Justine has extensive experience teaching in Victorian secondary schools and more recently has been teaching in tertiary teacher education. She conducts professional development in numeracy and mathematics. She's deeply passionate about mathematics education being accessible for everyone and for all students to have an opportunity to succeed. Let me also introduce you to our Victorian sales team. If we can just get their faces up for a few seconds and I'll let you wave out so that everyone gets to see your faces. So let's begin. Emma Kapler, she's the State Manager for Victoria. Carolyn, who looks after the northern suburbs. Kim, who looks after east and southeastern suburbs. And Marcus, who looks after western suburbs. Thank you, everyone. So without further ado, please let me introduce our first speaker, Dave Tout.
Okay, welcome to the webinar for Foundation Mathematics Units 1 and 2 and 3 and 4. This is about the textbooks that are part of the series Cambridge Senior Mathematics for VCE, along with General Mathematics, Maths Methods and Specialist Maths. Cambridge has never done books for Foundation Maths before, but as part of the redevelopment of the study design, we are doing books for the first time and we're very happy to do so. I will introduce two of our authors, Dave Tout and Justine Sakurai. We're very excited to have them as part of the Cambridge family. And in this webinar, they'll be talking about the approach of the books, the thinking that has gone behind it, how it connects to the learning outcomes of the study design, the areas of study, and the essence of what the study design is trying to get at. So our approach here, which Dave and Justine will go into detail about, is a very context-based approach. That is the approach of Justine and Dave, both as writers and as teachers, but it's also at the heart of the study design itself, and that's what we'll focus on today. Okay, over to you, Dave and Justine.
Okay, so we've decided to start here with a context because context is everything in our approach to this book. We believe that the context should drive the mathematics. And so we're going to pose a little sample to you. So we've got a car here, very expensive car, And students are my students are always very interested in buying a car. It seems to be one of the highest things on their priority list. And so why not use that as a starting point for their mathematical investigations? So when you've got this idea of buying a car and you've got the section in the chapter, the section of the textbook, where do you go next? So if we can flip to the next slide, and Dave will take you through the process.
Yeah, so one of the things about starting with the context is that the world actually is really rich in mathematics. And so like here, and one of our approaches is to start with a context and then to do some brainstorming about that context and what are all the issues around that context. And as you'll see here from a brainstorm about cars, you can see that there's a whole pile of things that you could investigate about cars. And that becomes almost too mind-boggling, and you could probably cover the whole curriculum just on this one topic of cars. So that's impractical. So often the key is to do that brainstorm, but to focus in. So you'll see on the bottom left there, and I think we can zoom in on the PowerPoint, you could just take that particular issue, which often kids in year 11 and 12, as Justine was saying, will be really, really enthusiastic about buying a car. So you might go through that process. We start our chapters with this sort of brainstorming idea, but then the focus has to then be on, well, what's manageable, what mathematics sits behind that particular topic, what are the issues and that around buying a car, and then what math investigations can you actually undertake.
So in the study design, there's a really strong focus on using investigations as an approach, and this is learning outcome too. So it's really important that as teachers we adhere to what the study design is asking us, but to use it in a way that really benefits our students. So if we look at this particular model here, which is a problem-solving model, which follows the investigation cycle, you can see that we start with the idea of formulation. So that is identifying the mathematics and deciding and planning which mathematics we will use. And the book, we've tried to make it so that we take the students through this process so that they learn the skills of formulating the problem and identifying the mathematics. And then, of course, the next phase is exploration of the mathematics. So it's really important that the students, once they've identified the maths, that they learn the key knowledge and key skills, which is learning outcome 1 in the study design, and they're able to apply those key knowledge and key skills so that they can use the mathematics. Dave, do you want to talk about the communication?
Yeah, and then the next stage in this, solving a problem in the real world and that's replicated in the study design and certainly in the investigations, is that there's no point in just doing the formulating and the investigating and doing the mathematics. You've actually got to do something with what you found. So that's what's described in the investigation as the communication, where you actually have to summarize the results of the analysis that the students have done and write it up and report it back. And that can be various ways of presenting the information. And again, it'll depend on the investigation. It'll depend on the audience as to how you might communicate the results. And you'll see in the study design that it also lists in the study design some examples for the sort of context or scenarios. And once you get your hands on our book, you will find that there is such a wealth of different sort of contexts. Cars is obviously one that we've used in there, but there's a multitude of investigations, and hopefully what we're providing is some different stimuli and different ideas, and then you can run with those when you're doing your teaching.
There are, we have tried to provide options for teachers to adjust their strategy based on the interests of the students in the classroom. Not everyone will be thinking about cars and buying their first car. They may already have one, or it may be a few years off. They may not want to buy a car at all and catch public transport or have some other solution to getting around. So we've tried to provide a number of options for the teacher next to almost every topic, so that they can choose how they may cover the topic to suit the interests of their students.
Very true.
So let's just look at one of the examples in the textbook. So, we've got this example here of dressmaking. And you can see we've got a stimulus question, which is asking students to work in small groups and thinking about the math skills and the math knowledge that might be needed to design and make clothes. So we're asking the students to do the identification of the mathematics, which you could see in that investigative cycle from the previous slide. This is the first step, the formulation. And we're asking the students to make a list of all the different math skills. We're asking them how important they think they are, and then asking them what other skills they might need, and then to try and broaden it out. And then, as Scott's just elucidated, this is just one, but we have many of these different ones covering many different contexts. So you can pick and choose to suit your students. But we do encourage you to get your students to go across a broad set of contexts so that they're expanding their knowledge as well.
And I guess the other critical thing, I think, is that what we're trying to, like Scott said and Justine's been explaining too, it's about you also taking on board this way of teaching mathematics. And so although you have this book with what we think is some pretty good rich ideas in there, but we're happy for you to then follow that model depending on who your students are. So, I think on the image that we've got here, if you're out in rural Victoria and, around you are huge crops that are being harvested, what's the mathematics about, farming and cropping? And, the mathematics that's involved in undertaking a task like this is extraordinary. And so the sort of the ideas that we're presenting, you don't have to feel that they're confined to what's in the textbook. Please use the structure and the ideas and then go off and do your own thing. And I think that's what's exciting about teaching mathematics this way, is that, the way you can go and the mathematics that can be learnt within a context is really very broad, and you can cover all of the areas of study. You're meeting the demands of the 3 outcomes and of the investigations, and you can target it for the interests of your students.
So I know, looking at this slide with the students standing there with their mobile phones, that you're all thinking, hang on, we're not allowed to use our mobile phones in the classroom or at school. But I'm just going to pose a question here, and that is, what technology do you most use in your life? And I bet you all have your phone on you right now. And the phone is the thing that you go to for everything initially. If you're looking something up on Google, you're going to jump on your phone if it's your closest device. Or if you need to send a message to someone, or a calendar. I bet a lot of you have calendars on your phone with reminders. So our phones are actually the most prevalent device in our lives, in our modern lives in Australia. And given that, you may have difficulties convincing your principal team to let you use phones in the classroom, you can simulate lots of these apps on the laptops or on iPads if your school has them. And so the technology in the curriculum really talks about contemporary technology and online and digital media, including software and applications based on computers, tablets, calculators, and handheld devices. So there is no limit on the technology. And we really tried this approach in the textbooks. We really tried to incorporate the technologies of the real world. And don't forget, if you can't use a phone, there are substitutes. You can find all these apps online. And if you're doing a section in the textbook on mortgages, use a mortgage calculator. Or, if you're using some kind of spreadsheet, use Excel or Google spreadsheets and teach the students the technology that they need in the real world. So, a lot of students that might have a job in retail after school, and a lot of them will need to use Excel because that's how they keep track of stock levels, or quite often that's where they record their hours of work. So we need to, as teachers, make sure that we are preparing our students for real life, and real life encompasses technology. So the book has a really strong emphasis on this, and we strongly encourage you to use the technology. So I suppose it's possible to do everything by hand, but that's not reality. And we're trying to prepare the students for successful lives and to be successful citizens in Australian society.
And also to look for shortcuts. If you are actually trying to accomplish some goal in the real world mathematically, you would want to do it without making a mistake, and you would want to do it as fast as possible. So if there is a generator or some kind of calculator or modeler or something online, you just Google it and find it and then use that, rather than going through the process of doing it by hand, even though that is important to learn about the guts of how it works. In reality, you would try and find shortcuts. So we've tried to include examples of that in the textbooks.
Sure do.
Okay, moving on to the problem-solving cycle in a little bit more detail, Dave.
Yep. And so here it was about sort of, in a sense, the connection between the problem-solving cycle and the learning outcomes. And as Justine said earlier, really the formulate cycle, the formulate aspect is about identifying the maths, which is really the areas of study in the learning outcome one. Applying the maths really is the exploring. So there is this parallel. And then the third learning outcomes we've just talked about is the critical one of using technology. And you'll see there technology and tools. Our toolkit could be an old-fashioned toolkit if you're working, as a carpenter or whatever. But these days it could be using drones. As Scott was just saying, it's looking for online applications. So if you want to work out how much mulch you need or soil for a gardening job, you can just go to a multitude of sites and they'll do the calculations for you. You then have to be aware of units. You'll see that there's a mixture of units there, but so there is that need to understand how the mathematics works. And then, computers these days are really, really important. And I think the last little dot point on here is about the communication, the last aspect of the problem-solving cycle. And again, technology will come in there too. So, this day and age, if you're not doing your presentations using some sort of, application, it could be presentation software, but it could be videos, it could be photos, it could be, a whole range of things. And that's what I think, is really encouraged here in terms of those investigations. And really what we're trying to do in units 1 and 2 is, in a sense, model investigations, so that when students get up to units 3 and 4, where it's part of the formal assessment process, then of course they're ready and prepared for actually undertaking those much more formal investigations at units 3 and 4.
Yep. Okay, we're just going to talk a little bit about the differences in the two books. So what the approach was for units. There was a lot of commonalities, obviously, but here's where we'll talk a little bit about the differences between the two books.
Yeah.
Okay, so sorry, Dave, go on.
That's right. It's worth thinking about what happens as you go from units 1 and 2 to units 3 and 4. And a number of things change. The structure of the problem-solving cycle and the structure of investigations doesn't change. But what is changing? And an obvious thing is that the complexity of the mathematics changes. So, we are expecting students at units 1 and 2, we're sort of supporting them to get in. They may be pretty negative about mathematics. So in a sense, units 1 and 2 is a pretty gentle introduction into the world of mathematics and solving problems, and hopefully encouraging students to be a bit more positive. But as they move up to units 3 and 4, the level of mathematics becomes much more sophisticated. So that's an obvious change, and that's reflected in the books. And the other thing is really that in units 1 and 2, you can scaffold and support the students in doing those investigations. Whereas once they get to units 3 and 4, it's much more like what happens out in the real world. Oh, I've got this problem I've got to solve. What maths am I going to actually bring in? So it's more open-ended, where we expect the students to go through that brainstorming process and actually make the decision about what mathematics to use, then use more complicated mathematics and probably present it in a more sophisticated way.
Mm. And then the other thing that we did is we made some very conscious decisions about the context. So in units 1 and 2, we decided that the context should be really local and really relevant to the students' personal lives. So what are the contexts that they're really engaged in at that year level? And that at that age, just from my own experience, I find that they're really self-focused. They're really interested in themselves and their immediate environment. So we put the context that would stimulate their interests, things that they were interested in. Getting a license, working on, counting their hours towards their L's, things that were relevant right now. And then in year 12, we shifted their focus and we made it more national and international. So we really took the students on a bit of a journey from, their own immediate environment, and then expanded it out and asked them to look wider, to the wider world, and even with elections and looking overseas, or gender pay gaps, to try and bring them right into, issues that we felt were important for them to look at. So context that would also be relevant in their lives, but perhaps they didn't quite, know it yet. So there was a deliberate decision to do that. And you can see there from the last arrow that that's how we did it. So the complexity increased. So initially in year 11, they were quite familiar context, ones that were easy to understand. But then as we stepped into the year 12, and particularly the end of the year 12 book, it's really extending them to think about contexts that they've never come across before, that unusual and unknown to them. And again, that idea is trying to prepare them for the exams that they might face at the end of year 12, and so that they're ready and able to face contexts that they've never come across before confidently, and be able to approach them, with a strong background.
Okay, well, here we'll talk a little bit in more detail about the structure of the textbook itself, how the chapters are structured, and give you some examples of the kinds of things that Dave and Justine have been talking about. So over to you, Dave and Justine, talking a little bit about how we've structured the book, why we start the way that we do, and how the chapters develop.
Go on, Justine, you do this one.
Okay, so the first chapter is quite different. It's an introduction to the way of thinking mathematically using the investigation cycle, and setting the students up for using those 3 steps and using them confidently. So, that's a bit different from normal textbooks. So that's chapter 1. And then from there, we decided to step through the key maths knowledge and skills in a way that would encourage students to feel confident as they were encountering the more difficult mathematics. So of course, we're starting with the idea of number and operating with numbers, and then from there we move on to the more difficult sections, which is the measurement, the statistics, and of course the finance.
And you'll see there on the right hand part of the screen that it's the structure within a chapter, and you'll see that, and each chapter is structured in similar ways, and you'll see the starting activities and the tuning in are really quite critical things, because the starting activities is an introduction to in a sense, the maths content, but set within the context. And the tuning in, I think, as the next slide, Scott, I think has got,
yes,
an example of what we mean by tuning in. And so in the tuning in bit is tuning into the topic and how that mathematics content is embedded within context. And there's 2 critical things. And as authors, it's been really interesting, because one of the challenging things is that in each of the chapters we have had in year 11, the units 1 and 2 book, we've got what's called an epic fail. Now, this is a really exciting one about the fact that this company in America thought they were going to outsmart McDonald's, and they advertised a £3 burger to compete with McDonald's £1/4 burger. And it was the same. It was, you got more for your money, except the campaign was a complete flop, because everybody in America thought that a quarter was bigger than a third. So we've got some really exciting epic fails. In units 3 and 4, we've gone to epic successes. So we've gone the other way around. We thought for units 1 and 2, maybe students would be more engaged with the disasters of mathematics as a way of connecting. So that there's a bit of fun in there, but the other important part in tuning in is what we tried to do is enable you as the teachers to introduce this concept within the context and ask students, and we've asked a whole range of, if you like, initial starting questions within that topic before we've even covered the mathematics in the rest of this chapter, with the idea that this is a way for you to do like a pre-assessment and get some diagnostic information to say, oh, I've got this group of students who I actually need to go back a few steps in order to get them up to scratch before we move on to the mathematics. So we think this is a nice way to start the book. One, I think it's attractive and interactive, but it's also a way for you as the teacher to find out more about what your students know about that maths topic.
And you'll find with some of these starting activities, the tuning in activities, that some of them might be practical. So for instance, in the measurement chapter, we actually ask you to do a practical activity with your students. There are written activities if you would prefer to do that. But, we've got the option there of practical activities so that you can see your students doing the mathematics in action. And that can be a really great way to engage the students. Quite often they ask, why am I doing that? Why do I have to study this? What's its purpose in real life? Well, we're hoping that this book answers those questions. But really, it's the idea of using metacognition for your students to understand that there's a purpose in doing the mathematics, and the practical activities can really, help the students to accept and then be a bit more engaged with the activities or with the mathematics. So we've got here, if we could do both of them at the same time, please, Scott. So, these are just little snippets out of the book. So, these 2 pages don't necessarily belong together, but what we want to show you is how we've structured it. So you can see we always start with a thinking task. So of course you've got your explanations and your worked examples, and we've got really thought hard about how to explain things. But then when you come to the question sections, it follows the structure. So the thinking task, and that's to ask your students to think about the material that you've just covered in the explanation, or think about the topic. Okay, so the thinking task might be practical, it might involve technology, it might involve class discussions, or it might involve individual work. And of course, you're the teacher, so we trust you to know how to implement this best in your own classroom. But that's a really important part, because that's keying the students in. And then we follow it with skills questions. Now, the skills questions are designed to actually just hone in and practice the actual skill. So what is the mathematical skill that I need to know here? Then quite often, and we haven't got an example here, but we've followed it with something called mixed practice. So we might jumble those skills up, because the research that's coming out now, which is linking, neuroscience and education research, is saying that when you mix the questions up, you're more likely to retain them in your long-term memory. So when you see the mixed practice, that's actually a really important section, and that's to help your students retain the skills. Then we follow that with a mathematical literacy, because literacy in mathematics is so important. If you can't speak the language of mathematics, you can't communicate it. So we're trying really hard to teach our students to speak mathematically and to understand the language. And there's so many words in maths which can be taken multiple ways. Dave's probably got some really great examples here. So we really want to get rid of any misconceptions, so that students can really clearly articulate the results of their mathematical investigations. And then the last part of the questions section is an application task, and this is where we really drill down into real life contexts. Of course, we've got real life context all the way through, but here we're asking them to go deeply into something and to practice, that investigative cycle. And we scaffold it quite often so that, we're thinking ahead about potentially what might be asked of the students in an exam situation, and trying to really prepare them for that as well, with the goal of, will they be successful in their real lives with mathematics? So this is the structure that we've got. So thinking tasks, skills questions, mixed practice, mathematical literacy, and then application tasks.
Mixed practice by its nature is not included in every single exercise. It is sometimes through a chapter, and it will recapitulate material that has gone before. That's not necessarily connected to that particular topic, 9F, for example.
Yeah. And often in the application task, it's mixed anyway by the very nature of an application is that you have to make that decision partly about what questions.
Okay, so we've talked a little bit about investigations in the context of the problem-solving cycle, and as it appears in the study design, but this is something that is explicit in the new study design, not just for foundation, but for general methods and specialists. But perhaps Dave and Justine, you could talk about how we've approached it for foundation mathematics, just in particular. So these appear at the end of every chapter.
Yep. So there's a second part to this slide, I think, Scott.
Okay.
Yeah.
Yep.
So again, this is just a bit of an extract of one of the investigations. So as Scott said, at the end of every chapter, there's two what we call, I guess, sample investigations that you as the teachers can decide to use or not, come up with your own. But again, what we try and do is model the problem-solving cycle. So they start with referring students back to the problem-solving cycle. And again, when we were talking about how we move from units 1 and 2 to units 3 and 4, units 1 and 2, they're scaffold structured with some guidance to the students. But again, they'll all be based on investigating a problem that is derived from the real world. Here it's about lawn mowing business. And then the student is taken through or expected to go through that process of formulating the problem, exploring it, doing the mathematics, and then communicating and writing it up. So we've got 2 per chapter. We hope there's plenty to select from, but again, we hope that you'll use them as models in order to maybe do your own thing.
That's right. And there'll be a lot more in the teacher resource as well that students won't have seen. Yeah. Okay, I think we are done. Thank you very much for listening. We'll now go to a question and answer session that is live. So we look forward to hearing your questions and hopefully we can answer them. Thank you very much.
Thank you.
So welcome back, everyone, and thank you so much to our author team and for such a great and insightful webinar this evening. I hope that everyone has learned something new and that you've created some level of bank of questions that you're hoping to get some answers to. So if I can get the authors back on, let's get started with the Q&A. If you could turn your cameras on. So welcome to Justine, Dave, and also Scott Halligan, who you would have seen in the video. He's actually a Cambridge publisher, so that's why you were seeing him in the video. I should have probably introduced him right at the beginning, so I apologise for that. But let's get started. Actually, Scott, you had a question you wanted to begin with, so let's start with that.
Yeah, just to kick things off, Kim, thanks. So, yeah, we'll start with a few questions for Dave and Justine and then get to the ones in the chat. Dave and Justine, this is for either of you. Just thinking about some of the kids who are likely to be coming into this subject, who may be lacking in confidence in relation to their previous studies, especially years 8, 9, and 10 leading into year 11. What allowances are we making for those kinds of students?
Do you want me to go first, Justine, or you?
Yeah, you go first with this one.
I mean, I guess my approach to that, or our approach to that, is that we tried to not make many assumptions about where we start, and that we know that the cohort of students who are going to go into foundation mathematics are probably not going to come in with terribly positive feelings about studying mathematics, and so they'll be feeling negative. They probably may well be lacking in some skills that we would like them to have when they start. So we haven't made any assumptions, and I think the critical thing is that I think what the approach we're taking is that we're starting with mathematics embedded within the context, and that's really the philosophy which you've heard in the webinar, and that I believe from certainly all of my years of experience is the way to engage those learners who haven't engaged with the world of mathematics. And what then happens is that we try and enable them to see mathematics that's in their lives, and then to be able to access that mathematics out of the real world. And then they have a purpose for learning the mathematics. Then if they don't know that mathematics, which is, also likely to be the case, we've tried to allow for them to be starting almost from, not quite from scratch, but from relatively low skill level. And so students who know all of that maths can jump forward, but those students who need to actually almost start from scratch, we've tried to explain how the mathematics works. And alongside that, then we certainly have access, if there isn't enough of that sort of level of mathematics within the textbook itself, then the online Support materials have even more stuff that we can then direct, or you as the teachers can direct that information, them to that information.
That's right, and there'll be some additional hot maths related content that comes from the lower year levels included in the online version of the interactive textbook. Some related questions. Maybe I can put this one to Justine. So two related questions. First of all, perhaps you could talk a little bit more, Justine, about the purpose of the starting activities that we have at the beginning of each chapter. Those are each A section, the first section in each chapter. And then we can move on to talk about the approach to differentiation in the book, how we've allowed for students who have varying comfort levels with, say, maths at a year 8, 9, and 10 level coming into the subject. So starting with the starting activities and then expanding on differentiation more generally.
So the starting activities, we all know as experienced teachers that we have to pre-test our students to figure out what they know and to work out, you know, what their specific needs are within a topic, so we can teach to point of need. And so the starting activities are really designed as a kind of a pre-test so that you can gauge what your students know. And you know, the activities are quite wide-ranging in scope, so that, you know, if the students know a lot, they can demonstrate their knowledge and show you that as well, but not in a test format, more in an activity format. And there's always a couple of starting activities with each chapter. So it's a bit of a novel approach, but, you know, one that's a bit more exciting pedagogically in your classroom, and hopefully your students would like to engage more with a starting activity than they would with the sit-down pre-test. So it's got the same purpose for you to collect data and for you to understand where your students are at. And I guess then that leads really nicely into the next part of your question, which is about differentiation. So we all know how in our classrooms we're differentiating to so many different points, and it depends on which pedagogical model your school uses, but, you know, most schools identify 5. And if you're looking at your 5 different groups, or 3, I know some schools work with 3, that you can, once you've established where your students are at, you can use the book very easily to pick out the different questions that would suit your students at different levels. So we step the students through different skill activities, and then we have application questions. So you can easily choose the application questions or the skill questions which suit your students' point of need.
Oh, you're on mute, Scott.
Yeah, and then I lost my mouse as well. I was just going to say that the students who tend to be more comfortable can probably spend more time on those applications tasks and the things like the investigations and all those things related to problem solving. All right, Kim, perhaps we'll get to some of the questions that are in the chat.
Good. So let's start with Brittany. Would the Unit 3-4 exam have similar style questions that are open-ended?
Brittany, I wish we had a crystal ball for you. Of course, that's a question for VCEE, one that we can't answer. So, you know, we could take a bit of a guess, but it would really be a guess. Just keep in mind that this is new. This is a brand new study design. So we've never had a 3-4 foundation before. So we don't know. I would assume that VCEE, I'm just you know, I can't speak apart from assumptions here, but I assume that they will be putting out a sample exam. But if we follow the study design, there's some pretty clear clues in the study design as to how we think it might look. I'm sorry, I can't be any more specific than that.
And those clues have been transferred into lots of supporting material along those lines throughout the book, and also will be in the supporting resource, the teacher resources and so on. And as we learn more, we will put more up there to support that.
That's great. Thank you. Rachel, will universities accept foundation maths as a maths for uni entry?
Another VCAR crystal ball question. I'm pretty sure that it will not be counted towards studying mathematics at university or as a requirement. This study was really designed for those students that are interested in doing a trade or working in an industry. And I would assume that if you wanted to go on and do any maths at university, that you would have to do a bridging course after this course.
Okay, thank you. One from Craig here. Any thoughts about doing VCal numeracy resources?
That's a good question. The more questions like that we get asked as publishers, the more we will consider doing that. We're certainly leaning more towards doing something along those lines than we ever have before. And yeah, that's about as much as we'll say at this point. I know there's another question down there, Kim, from Jenny. Do you think that this resource subject will be something that we should consider in the new VM certificate? There's another question about VM numeracy that we'll get to in a second.
What we can say is that both Justin and I are passionate VCal people, have been, and so there are synergies.
Yes,
with this book, yeah.
Synergies, but you couldn't translate it straight across though either, because different study designs.
Let me ask this question from Gregoria. There seems to be some crossover between the contexts and the numeracies that need to be covered in the new VM numeracy, formerly VCal course. Could you see this resource being used for numeracy? That might be a fairly common question that people are wondering about, Justine.
Yeah, I see the study designs as being quite different in some ways. I mean, there's as Dave said, there's things in common because there's similar levels, but the foundation maths is a slightly higher level of mathematics than the new vocational major will be. And from my understanding, the vocational major is really competency-based learning. So there's aspects of that which of course would be difficult to translate over from the textbook. So this is a difficult question to answer. I'll let Dave have a go.
Yeah, but I think they're all starting from a basis of starting with a context, and that's the similarity, I think. And then it's about what's made explicit in each of the study designs then takes you in, slightly different directions. And of course, there's no exam, no formal investigations in units 3 and 4. So there's significant differences. But I think in terms of the fact that, both curriculums sort of in a sense, the frameworks and the delivery is about starting with the context, then that's where the similarity is. And then you'd have to realise that there are those differences within the mathematical content and with the formalities of what's expected in foundation maths versus vocational major.
And the vocational major curriculum has different areas of study for each unit, so you'd have to be really careful about picking out your context, your area of study. Yeah.
Any further questions in the chat?
Yeah, we have a few more. Yes. From Benjamin, is the textbook for 3 and 4 ordered and grouped based on skills or activities investigations?
Throw that one over to Justine first of all.
Yeah, can you rephrase it slightly? Sorry.
Is the textbook for units 3 and 4 ordered and grouped based on skills or activities / investigations? Maybe you could just talk about just the structure of the book in general, how we made the decision to structure the chapters in relation to the study.
So neither. It follows a study design. So whether, there's 4 areas of study, and so the book follows the 4 and doesn't, do it in the same order, but uses the 4 areas of study and then unpacks the areas of study into different chapters. And then within each chapter, you have skills and applications. So every section, I should say, every exercise has skills and applications. So we've really got applications right throughout the entire book. But, obviously there'll be a number of chapters that are about area study 1, some chapters that are focusing on area study 2, chapters that are focusing on the financial, and chapters that are focusing on the measurement. So, and we also have some investigations chapters. So chapters where the students really just focus in on practicing those skills for the SACs, where they have to do the long investigations. Does that answer the question?
Yeah,
Okay.
I think so. Yep.
Yeah. Ty has said, any thoughts regarding the issue of students who should be doing methods specialist sitting this subject because they think they will do well? What would your advice be to schools managing this?
Probably throw this one to you, Justine, as someone who has taught all of these subjects very recently. So what would you say?
Yes, I will out myself. I have taught methods special for the general foundation. So yes, I would not encourage them to do this, because this subject was not designed or written for them. I'm not sure, but I would assume that VCAR will have a penalty if you do, 3 maths, or if I'm not across what VCAR's decided there in terms of the ATAR, but it would be unreasonable to do methods and foundation. This course was not written for them, so it wouldn't stimulate them, it wouldn't enhance their studies. There are some aspects of it I think that the method students should have, like the financial chapters. So I'm going to contradict myself there. But, that's another question for VCAA, unfortunately.
So Janine has said the new VCAL numeracy needs, actually she means VM numeracy, needs resources. Please put something together for us. And then I can move down to Joseph. Some universities are saying that they will accept foundation maths for some courses. Consult with your careers counsellor and ask them if their careers network has any updates. So
thank you for that. Yeah.
Yes, thank you, Joseph. Kayla, as our year 12s will be starting next year without having much experience with mathematical investigations in year 11, what are your thoughts for preparing them?
Dave?
Yeah, I mean, I just say, well, start now in units 1 and 2. I mean, I think it's, it basically means, start modelling that practice as of now. I mean, the maths content hasn't changed very much. I mean, the financial and consumer maths is certainly new, but, the way of approaching that is to, get students to investigate something to do with, money in their lives or whatever. So I think it is possible, use the advice that's in the study design about the investigations. I mean, it's quite clear about the 3 stages, and start modelling that now and using that throughout the teaching as you're going through this year so that they're prepared for it next year.
Great. Well, it's pretty perfectly on time. We've come to the end of the questions. So unless there's anything more that you would like to communicate.
I might just throw one more question to both Justine and Dave, because it has been something we've tried to think carefully about. There were some questions earlier about calculator use and whether we would be, what is the relation of the foundation study design in terms of its CAS calculator or specific mandates for various calculators. Just talking more generally, could you speak, Justine or Dave, a little bit more about why we've chose, like what types of technology are included throughout the book, and why we've made those choices, whether those are spreadsheets or apps or all those kinds of things, and how we've incorporated all of that, and how it connects to the outcomes in the study design.
I mean, I'll start briefly and then maybe throw it to Justine. But I mean, it seems to me that, for this cohort of students, we want them to use the tools that are available in the world around them, and not the tools that are used just within a maths classroom. And what research is saying in terms of, what adults use in their lives. And basically that means tools that are applicable and that will help them solve the problems that they're facing. And so therefore it is about using, common devices and mobile phones. So certainly there is an assumption that you'll have to get approval to be able to use mobile phones within your classroom, because, the sorts of apps you can download and use on your phones to do measurement and all of that stuff and measure angles and a whole range of things are things that people will use out there in the work in the real world. I mean, we've certainly got a pretty strong emphasis on using spreadsheets. A lot of research about, you know, what people actually use in workplaces are spreadsheets, and yet workplaces are complaining all the time that in fact their students come to them without that capability. So, you know, we're building in those things up, but there's a lot of times we'll say, well, go and find an app, because we can't really demonstrate an explicit app. So it is about going and finding out what's accessible and what you have access to. And so that's the really big emphasis, is on using a range of different tools and applications. Justine?
And I'll give a personal example just to add to what Dave's saying. You know, one of my children who's studying at university, she's got a job in retail and they have to use Excel. She said to me, why don't I learn this at school? And then, you know, as she, you know, was working through her first job a couple of years ago, you know, she wanted to know about taxation and how much she was going to pay. So I showed her a taxation calculator on the internet. You know, so there's all these tools that we use in real life. If, you know, if I was going to go out and think about, you know, not in this climate, but in another world, I was going to buy a property, I would go and use a mortgage calculator. I wouldn't get out an old-fashioned calculator and try and do the things by hand. I would use the tool that's available to me. So it's about skilling the students for the tools of the real world.
Yeah, and it just matches the context-based approach. I mean, the context determines the appropriate technology. And if we're modeling real life, then what do people actually do in real life? Generally, they look for shortcuts and they look for the best way of getting the answers that they want. And we certainly haven't skipped the understanding part of that in the book. There's obviously an emphasis on understanding how apps work and what is, if there is a specific type of calculator, what is it doing? But we're not going to make students just spend hours doing certain types of calculations that they don't need to do, or using technology that they're not going to use if they weren't at school.
I actually want to ask there's one little question just popped that I think is relevant. Are there answers provided for the skills questions, I should say?
Yeah, there'll be answers.
No. Your teachers have got to answer all those.
Don't listen to Dave. Of course, we'll give you answers.
Yeah, there will be answers to all those types of questions. And when there are a lot of activity-based questions, not just in the exercises, but throughout. And those kinds of questions that require a little bit more than just, or aren't appropriate to have just a single answer in the back of the book, those will be supported by teacher notes, and there'll be some additional material in the solutions and things like that. So yeah, there'll be a lot of guidance for the teacher in addition to providing the answers to those types of questions.
Wonderful. Thanks, Scott. Well, that brings us to the end of the Q&A. So thank you, everyone. Thank you. I do have a few slides, so don't close off the webinar just yet. But if we can say sayonara to all the authors, thank you so much. And I will just run through just a few slides here so that you have an idea of pricing and availability. But I did want to also let everyone know, and just a reminder that if we weren't able to get to any questions, but actually I think we've got through to everybody there really. There was only a couple of people that had asked questions about pricing and availability, so I'm able to communicate directly with you here. But everyone will receive their recording within a week. So a recording of the whole webinar. And there's also a feedback form available on that or inside that email as well. So make sure that you give your feedback. We really learn a lot from those feedback forms. So take the time if you can, please. And any questions that you have on whether or not the product that we have is what you're looking for. If you want to get some real detailed information about what these books are about, please reach out to our consultants as well. So I'm going to introduce those, our consultants again on the screen through these slides, but I just wanted to remind you of that too. So let's get to the slides. If we can move to the second one, please. So the availability, page proofs, units 1 and 2 is July, and 3 and 4 August. And of course, publishing dates, which is the most important part, units 1 and 2 November, and 3 and 4 in December. Next slide, please. So the price points here are a little bit different to the other books in the series. So just so that you're all aware of that, print and digital $79.95 and digital only $59.95. Teacher resource is the same across the board though, $149.95. We can move to the next slide, please. So just a little reminder, it's good to put all these faces back up onto the screen so you know exactly who it is that you need to be communicating with. This information is also on our website, so know that you can reach out to anybody at any time. We're always open to any questions that you have. We'll come out and meet with you and go through any PD or work through any questions that you have that we can show you something with as well. If you also have any further questions for our author team, you could reach out via our consultants with those questions too, and we can make sure that we get, you know, exactly the response that you're looking for. If we can move to that final slide. I think I've really covered all of that, but most importantly, I really wanted to say a huge thank you to the authors for their contributions this evening. So from Cambridge University Press, and I'm sure from everyone else watching the webinar this evening, a huge thank you from us. And please, everyone, stay warm, stay safe, and good evening to you all. Thank you for coming.